Having spent quite a bit of time looking at microevolution and the concept of population genetics, and now the evidence for evolution, the idea that existing species have come from pre-existing species and have diverged from common ancestors over time, we need to move on and look at macroevolution, and that is, how do new species actually appear and evolve? And so before we do that, we need to look at just exactly what is understood by a species. Well, for a start, it's actually very hard to say exactly what a species is. We have working definitions which are useful for talking about species, but these are limited in their own way as well. So here's a couple of working definitions for species. You could talk about a species as a group of interbreeding, or at least potentially interbreeding individuals that are reproductively isolated from one another. So what does that mean? Well, perhaps to put it in another way, we could talk about a species, so we could say that two individuals belong to the same species if they can successfully mate and produce healthy, fertile offspring under natural conditions. Now, either of these two definitions, it's fertile, that word there, either of these two definitions is okay as a working definition. I like the second one because it tells us something about, or helps us to kind of work out whether two individuals could belong to the same species. Of course, these individuals have to be alive and mating for us to be able to see whether this is possible. But one of the key things about this definition is that, first of all, we can actually we have criteria for seeing if it works. So first of all, they have to be able to successfully mate. They have to be able to produce healthy and fertile offspring, that is, offspring that themselves can go on and mate successfully, and they have to do this naturally without human interference. So if two individuals can do this, then technically they belong to the same species. If they cannot do this, then we would say that they are reproductively isolated. So if two individuals cannot successfully interbreed or mate, then they are reproductively isolated from one another, in which case they are not the same species. Now, this is a good working definition for living things, but of course things that are extinct or part of the fossil record, we can no longer measure this easily. We can't see whether they could successfully mate or not. So sometimes we have to use other definitions, which may involve similarities in morphology, so similarities in body structure and behaviour, and we might need to see if we can infer from morphology, that is body structure, whether they were close enough to perhaps have been able to interbreed. So this is the kind of tricky bit when it comes to studying these kinds of things. Are often made up of different populations, often in different habitats. And distinct from one another. So not all species are found in the same place. So a species can be distributed over a wide geographical range, perhaps even in different parts of the world, but if they actually were brought back together, they could successfully interbreed. These subspecies, races or varieties are generally determined by degrees of reproductive isolation. That is, because they're widely separated from other populations, they, to various degrees, may not be able to always successfully interbreed with other members of the species to one degree or another. So often, as different populations become more and more unlike each other due to local variation and local selection pressures, then they're sometimes, as I said, classified as subspecies, races, or varieties. So often they can still interbreed, but they're becoming more and more different because, as I said, of their different habitats, their different environments. And so they may well be on the way towards becoming different species.